Hi guys, back again. We're doing 9.5 today. So in our notes, I'm gonna write 9.5. And today's lesson is about the mean absolute deviation. Now, if you know anything about English, we know first of all what mean means in math, right? We know how to find the mean of something. That's when we take all of our data and we add it up and divide by how many numbers we have in the set. And then deviation, if you think about what deviation means, they say you deviate, so how far something is from something. Like if you deviate from a plan, you're leaving your original plan to go to make another plan. It's the same thing here. You're gonna have your mean value, and you're gonna see how much each piece of data, how far away it is from our mean. So we call it in math, the MAD, M-A-D, mean absolute deviation, MAD. All right, so we're gonna start over here. We're gonna start with our vocab word, mean absolute deviation, or MAD, as I said. It's an average of how much data values differ from the mean, which is basically what I just said. So we're gonna find on average, how much our data values are different from the mean. All right, so there's 4 steps when we find the MAD of a problem. Our first step is to find the mean of the data. We know how to do that. We know how to find the mean. We're going to take all of the numbers from our data, add them together, and divide by however many there are total. That's going to give us the mean. Step 2 then is to find the distance between each data value and the mean. So we're going to see how far away each number in our data is from the mean. Step 3 is to find the sum. Sum means add. So find the sum of the distances that we had in step 2. So going back, how far is each one away? And then we'll add that up in step 3. Finally, step 4, we are going to divide that sum that we found in step 3 by the total number of data values we have. And that's going to give us our MAD, our average of how much data values differ from the mean. All right, so let's try it. Here's the example. It says you record the numbers of raisins in 8 scoops of cereal. So maybe this is a cereal like Raisin Bran. It says find and interpret the MAD, or mean absolute deviation, of the data. So I put these in numerical order for you already. Let's just say in the first scoop of cereal, you only had 1 raisin in it. In the second scoop, you had 2. In the third scoop, you have 2 raisins. In the fourth scoop, you have 2 raisins. In the 5th scoop, you have 4 raisins. In the 6th scoop, you have 4 raisins. The 7th scoop, you have 4 raisins. And then in the 8th scoop, you have 5 raisins. We had said step 1 was to find the mean. Well, that's easy. We're going to add all those digits up and divide by however many we had. So we have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So I'm going to add them all up. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 7 is 5 plus 2 is 7. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19. And then 19 plus 5 is 24. Now we're dividing by 8 because we had 8 pieces of data in there. So 24 divided by 8 means I have a mean of 3. So that's saying on average, I have 3 raisins in a scoop of cereal. Step 2 was to find out the distance between each data value and the mean. Well, if we look back at our first data value, we had said we got only 1 raisin in our scoop of cereal. But we had said on average, our mean, we had 3. So how far away is 1 from 3? Well, 3 minus 1 is 2 away. We're 2 away from the mean. In scoop 2, we had 2 raisins. If we said the mean was 3, how far away is 2 from 3? Well, it's only 1 away. It's 1 away. Our third scoop had 2 raisins. How far away is 2 scoops from 3, our mean? That's also 1 away. And then our fourth scoop, we also had 2 raisins. How far away is 2 from 3? That's 1 away. Our 5th scoop, we had 4 raisins. How far away is 4 from 3? Well, it's 1 away as well. It's just 1 away in the opposite direction. Our 6th scoop, we had 4 raisins. How far away is 4 from 3? That's also 1 away. 7th scoop, we had 4 raisins. How far away is 4 from 3? 1. And then finally, our 8th scoop, we had 5 raisins. How far away is 5 from 3? That would be 2. So it does not matter. You're always taking the bigger number and subtracting it from the smaller. So it doesn't matter if our mean was the bigger number or if our data value was the bigger number. You're always going to take the bigger one minus the smaller one. So this was 3 minus 1, 2. 3 minus 2, 1. 3 minus 2, 1. 3 minus 2, 1. Now we're going to switch it up because all of a sudden our values got bigger than the mean. 4 minus 3, 1. 4 minus 3, 1. 4 minus 3, 1. 5 minus 3, 2. Step 3 says that I'm going to add those numbers up. So I had a 2, a 1, a 1, a 1, a 1, a 1, a 1, and a 2. So for step 3, I'm going to add those all up. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. 7 plus 1 is 8. And then 8 plus 2 is 10. That's the sum of my distances when I add them all together, is 10. Step 4 says divide that sum by the total number of data values. Well, we just said we had 8 data values. There was 8 scoops of cereal that I had taken. So 10 divided by 8 gives me 1.25, or 1 1/4. So this means that the data values differ from the mean by an average of 1.25 raisins. That's saying that on average, if I take my scoop of cereal, I'm going to have 1.25 raisins away from my mean, which we said was 3. So they say our MAD is 1.25. Let's try it again. In this example, it says find and interpret the mean absolute deviation, our MAD, of the data 5, 8, 8, 10, 13, 14, 16, and 22. Step 1, find our mean. We have 1, 2, 3, 4, 5, 6, 7, 8, again, data values, so I'm going to be dividing by 8 in this case. I got to add them all up first. So 5 plus 8 is 13, 13 plus 8 is 21, 21 plus 10 is 31, 31 plus 13 is 44, 44 plus 14 is 58, 58 plus 16, 58 plus 16, so 68, 74, 74 plus 22 is 86. So we have 86 divided by 8, which is going to give us 10.75, or 10 3/4. 10 3/4. Step 2 says the amount each is away from the mean. So we have to figure out how far each data value is from our mean. So how far away is 5 from 10.75? Well, if I take my bigger number, 10.75, and I subtract 5, I get 5.75. So my first value is 5.75 away. My second data was 8. How far away is 8 from 10.75? Well, 10.75 is bigger, so 10.75 minus 8 is 2.75. So 2.75 away. My third data value was 8. How far away is 8 from 10.75? 10.75 is bigger, so I'm going to do 10.75 minus 8. I get 2.75. My fourth data value is 10. How far away is 10 from 10.75? Well, 10.75 is still bigger, so 10.75 minus 10, that gives me 0.75. Fifth number was 13. How far away is 13 from 10.75? Well, now the 13 is bigger, so I'm going to say 13 minus 10.75. 13 minus 10.75 is 2.25. Our sixth value is 14. How far away is 14 from 10.75? So 14 minus 10.75 is 3.25. 3.25. Seventh value is 16. How far away is 16 from 10.75? So 16 minus 10.75, that gives me 5.25. And then my last one, 22. How far away is 22 from 10.75? So 22 minus 10.75 gives me 11.25. So step 1, mean 10.75. Step 2, find all the distances that it is away. Step 3 is to find the sum of those distances. So now I just got to add my distances that I found in step 2. So 5.75 plus 2.75 plus 2.75 plus 0.75 plus 2.25 plus 3.25 plus 5.25 plus 11.25 gives me 34. That's my sum, 34. Step 4 then is to take my sum, 34, and divide it by how many pieces of data there are. We said there was 8 data values. So 34 divided by 8, that gives me 4.25. So my MAD, my mean absolute deviation, is 4.25. On average, my data value is going to be 4.25 away from my mean. That's my MAD. All right, one more. Find and interpret the range, the interquartile range, and the mean absolute deviation of the data. Oh, so now this is combining all of the concepts that we have done since yesterday, the range and interquartile range, and then what we did today, the MAD. All right, so let's write these down. I'm going to start by writing my numbers in numerical order. So of the data they gave me, my first data value in numerical order would be 11. My second would be 12. My third would be 15. My fourth is 16. My fifth would be 20. My sixth is 20. And then my seventh is 25. So here are my 7 numbers, 1, 2, 3, 4, 5, 6, 7. I'm going to start by finding my range. We had said yesterday that range is the highest number minus the lowest number. So my highest number is 25. So I have 25 minus my lowest number, which is 11. 25 minus 11 is 14. So my range is 14. The second question they asked us to find was our interquartile range, our IQR. Our IQR, we had said we had to do the third quartile minus the first quartile. That one is a little bit harder. So going back to our data here, we have to find our median, the one directly in the middle. So not the first or the last, not my seconds, not my thirds. My median is right here. My median is 16. That means these 3 numbers would be my lower half, and these 3 numbers would be my upper half. Since I need my third quartile and my first quartile, we had said my first quartile is the median of my lower half. So I have to find the median of this. Well, it's not my first or my last, which means this one right here is right in the middle. So that's going to be my first quartile. My third quartile is going to be the median of my upper half. There's 3 numbers there, so it's not my first or my last. It's going to be the one right in the middle. So that one is my third quartile. So my IQR is the third quartile, which is 20, we just found out, minus my first quartile, which is 12. 20 minus 12 is 8. Now we got to find that MAD. We had said step 1 was to find my mean. All right, let's add these numbers up. 11 plus 12, that's 23. 23 plus 15, that's 38. 38 plus 16 is 54. 54 plus 20 is 74. 74 plus 20 more is 94. And then 94 plus 25 is 119. Now I have 1, 2, 3, 4, 5, 6, 7 digits. So I'm going to do 119 divided by 7. We'll do our long division here. 119 divided by 7. Let's see, 7 doesn't go into 1, but it will go into 11 one time. 7 times 1 is 7. 11 minus 7 is 4. Bring down my 9. 7 goes into 49 7 times. So 17 is going to be my mean. That was step 1. Step 2 said find how far the distance, how far away each data value is from the mean. So let's see. If my mean is 17 and my first number is 11, what's the distance between them? Well, 17 minus 11 is 6. The second set of data is 12. How far away is 12 from 17? Well, 17 minus 12 is 5. My third number is 15. How far away is 15 from 17? 17 minus 15 is 2. My fourth piece of data is 16. How far away is 16 from 17? Well, 17 minus 16 is 1. My fifth piece of data was 20. How far away is 20 from 17? Well, 20 minus 17 is 3. Sixth number is 20. How far away is 20 from 17? 20 minus 17 is 3. And then my seventh piece of data was 25. How far away is 25 from 17? Well, 25 minus 17 is 8. Step 3 says I'm going to add those together. 6 plus 5 is 11. 11 plus 2 is 13. 13 plus 1 is 14. 14 plus 3 is 17. 17 plus 3 is 20. And 20 plus 8 is 28. My fourth step is to take my 28 and divide it by however many pieces of data I had. We had 7 pieces of data. 28 divided by 7 is 4. So my MAD is 4. Solved the problem, got my range, got my IQR, and I got my MAD. Your job is going to be doing that 9.5 practice. I'm going to put it up on Google Classroom. You do just the practice part like you're used to. If you have any questions, you may get a hold of me, text me. There's also YouTube videos out there that you are free to watch. There's a whole web full of stuff. You know how I like Math Antics. Try them first. They're usually really well, they work really well, and so is Khan Academy. Try them if you didn't understand it. They also have a whole video out there on MAD. I hope you guys enjoyed this, and I hope you guys enjoy trying to do this on your own for your homework. Bye, guys.